What word do you see in equations? Yes, sir.
Equal.
There you go. Basically, it just means it has an equal sign in it. So, examples. X plus 3 equals 7. Y minus 6 equals 10. Z divided by 4 equals 20. And I'll go back to A times, well, let's just write it this way. 3 times A equals 12. These are all examples of equations because they have something equal to something else. Now I'm just going to ask you, what do you think this answer is going to be? Yes?
4 plus 3.
All right, so we know x is going to be equal to 4 because we know 4 plus 3 is 7, yes? So we can say right here, x is equal to 4. What is y going to equal to here? Something, take away 6, and you have 10 left over, yes?
16.
Yeah, it's going to be 16. Nice. How about right here? You divide something by 4, and you have 20. Yes?
5.
So 5, here's 5. I'm going to divide it into 4. Do I have 20 now? So I'm going to divide it into 4. So 1, 2, 3, 4, and then I have to split this up into 4 sections. So does that mean I have 5 things now? Does that make sense? Do I have a 20 now? No, I have 4 fingers, and I cut this into 4 pieces. So it's not 5. You're thinking 5 times 4 is 20, but I'm saying you have 20 things left over after you divide by 4. So that is kind of a tricky one, yes? Yes? 80. There you go. You have 80 things. You divide it. So if you have $80 and you divide it among 4 people, each person is going to get $20, yes? 20, 40, 60, 80. Oh. How about this guy right here? What is A going to equal to? 3 times something is equal to 12. Yes? Yeah, 3 times 4. I'm going to leave these guys up here because we're going to go over that in a little bit and to see what we can do. You'll see a nice little shortcut to figure this out. Let's look at the example on page 14. There are 6 more girls and boys in a classroom. So in our notes, we're looking at this example here. So we have boys and we have girls. I don't know why I put Q for girls because I'm thinking quarters. We have boys and girls. It says there are 6 more girls and boys. So it says there are 12. So if I look at this, for boys, let's say I don't know how many boys there are, but there are 6 more girls, correct?
Yeah.
So kind of doing what we did for the practice problems. For the girls, it's going to be the same size box plus an extra 6. Correct? Now, so I have 2 boxes and then 6 girls. There are 40 students in a classroom. Well, that's a big classroom. Now, how many girls are there going to be?
20.
How'd you get 20?
Because divided by 2. 40 divided by 2.
But the thing is, these are not the same. We have that extra 6. We can't divide unless we have the same amount of something. Here we have boys, but we have girls. We have more girls than boys. So we have that 4. So you're saying 40 divided by 2? You do divide by 2, but you can't divide yet because these 6 are in the way. So what should I do with those 6? Let's get rid of them. I can't divide unless I only have a box up here and a box up here. But I don't have only a box. I have these 6 things. So we'll just do what she says. We'll just take away 6. So we'll do that. So that just means 40, take away 6, which is how much?
34.
34. Now what can I do?
Now you can put
Because now I know if I take away, that's 34. Now I can divide by 2. 34 divided by 2 is 17. So this is a 17, and that's a 17, yes? So I know there are 17 boys, but how many girls are there? Yes.
23.
Yeah, 17 plus 6, which is 23 girls. So to figure out the boys, if I look at this, let's say we didn't know that was 17. Let's call that X. So if this box is called X, what should we call this box?
X.
Also X. Now, we know that when we add this plus this plus this, what should the total be?
44.
It should be 40, right? So we know we have X plus 6 equals 40. How else could you write this X plus X? Yes.
So, wait, 17.
How else could you write this X plus X? Yes, ma'am.
2x.
All right, so you can rewrite it as 2x plus 6 equals 40. Now, what did we do to find our answer? So the first thing we did, we got the total, that 40. Let me rewrite it here. First thing we did, we had our answer, and then we subtracted 6. So we did 40 minus 6. So we got that and subtracted that, and we got 34. What did we do with that 34? We divided by 2, which is, and that's how we did that. Now I want you to look at this problem. What does this thing say to do?
2x.
And what does 2x mean?
X 2 times.
Yeah, so you're multiplying by what?
X 2.
You're multiplying by 2, yes? What did I do here? Divide by 2. What does this say? What does that say?
Plus 6.
To add 6. But what did we do?
40 minus 6.
We subtracted 6. So what could you say? How would you reword this?
It's opposites.
You have to do the opposite. What did we start with?
40.
And 40 represented the total.
Minus total.
So you get the total. You start with the total and just do whatever, you start with the total and just do whatever the opposite of that is. And then do whatever the opposite of that is. Got it? Now let's see if that works over here. Take a look at these problems. What's the total? What does that say to do? So what's the opposite?
Subtract.
What's 7 minus 3?
4.
Oh, isn't that what we had here?
Yeah.
Oh. What's my total?
10.
What does that say to do?
Subtract.
So we just do the opposite. What's the opposite of subtracting 6? What's 10 plus 6?
16.
Oh, isn't that what that is right there? All right. What does this say to do?
Divide.
By 4. What's the opposite of dividing by 4?
Multiply.
So what's 20 times 4?
80.
Oh, isn't that what we got there? This means to do what?
Multiply.
Well, what's the opposite of multiplying? Well, what's 12 divided by 3?
4.
Oh, isn't that what that is? All right, so here's a nice thing that you learned in math today. When it comes to solving equations, start with the answer and do the opposite of whatever that says to do. Start with the total. Start with the total. And then what do? Do the opposite. And that's what you're doing today. If you enjoyed today's video, please subscribe. Or check out this video over here. If you want to see my previous video, click this one over here. Thank you for watching. And have a very mathalicious day.